Friendly reminder that water isn't always H2O. The water we search for beneath Europa's ice, or on Ariel, a moon of Uranus, may be able to support life, but that doesn't mean it's chemically identical to our water. You learned this in school, but really, it's this. And all of these options are because of isotopes. If you fell asleep in chemistry class, like I did, then you may not remember, but we categorize elements based on how many protons they have. So hydrogen has 1, helium has 2, so on and so forth. So when the number of protons is the same, but the number of neutrons is different, that's called an isotope. Isotopes are made from stars or radioactive decay, and they can provide really unique signatures on the backstory of, for example, where the water in a certain comet came from. Hydrogen can come in these 3 forms, so to speak. D2O, otherwise known as heavy water, has deuterium instead of hydrogen, and it's in our water. While rare, you do drink it in very small quantities. Water with deuterium usually forms in cold environments, so a comet far from the sun is more likely to have a higher concentration than in the asteroid belt, which is closer to the sun. It's believed that in Earth's early life, it was too hot for water, but as it cooled, water was delivered via asteroids, which has a more similar deuterium concentration. But there are some weird things happening with this, so we're not entirely sure yet. What would be really cool is if the water on Europa or Enceladus has a completely different concentration of deuterium, because that could mean it came from a completely different source than from wherever we got our water.